Okay, we're going to go through a couple of binomial theorem type questions. Okay, they're going to go from slightly easier to slightly harder, and if you haven't already had a go at them, just pause the video and then have a go, write them down, and then come back and check through them. Okay, I'm going to go through the first one. So it says write down the expansions of, and then we have to do the expansion of both of them. We basically have to expand 1 plus x cubed and also 1 minus x cubed. But it's only 3 marks, which means roughly 3 minutes. So we've got to be mindful of time here. Now, first thing we do whenever we are expanding, and it's a non-calculator question, this one, we're going to write out our Pascal's triangle. And sometimes you might want to work from the middle outwards as well. And then what I often do is I write down my power of 0, 1, 2, 3, 4 to help me keep track of this. So I'm going to need this row here because I need my power of 3. So I'm just going to jot down 1, 3, 3, 1. I'm going to do my terms going down so I can keep track of them. Now I know with the binomial theorem, I need to then multiply the first term and the second term of the bracket. So I'm looking at the x, 1 plus x here. Okay, so I'm going to do that in all of them. And then I have to change the power. So what we notice here is this power decreases. Oops, I'm getting ahead of myself. I'm not going to remake the video. I'm just going to go back to here. Sorry, 3, 2, 1, 0. And then we have 0, 1, 2, 3. So these powers here need to add to make the power we had originally, and they're one of them decreases and one of them increases. Now we can just work them out. So we're going to have 1 times 1 cubed, which is just 1, times x. So it's actually 1 times 1 cubed times 1, which is just 1, because this one is x to the 0, which is just 1. Now we're going to have here 3 times 1 squared times x, which is just 3x. We've got 3 times 1 times x squared, which is 3x squared. And then we have 1 times 1, because anything to the power 0 is still 1, times x cubed, which is x cubed. So the expansion of 1 plus x cubed is going to be 1 plus 3x plus 3x squared plus x cubed. The expansion of 1 minus x here is going to actually alternate with each one. So what I mean by this is, if you think about this logically, this one is going to become negative x, but it would still be 1. So the first one would still be 1 as a positive. The next one would be a negative here. So that would become a negative, this would become a negative. Okay? So actually, my signs are going to alternate. So I can just assume, because I know if I did this whole thing again, and you can do the whole thing again, but you don't always have the time. See, here. Okay, so I've alternated the power. So this is my plus x, this is my minus x. Okay, and that's it. Okay, I'm going to work on to the next one here. And I'm going to show you the different method instead of writing out the Pascal's triangle and going through it. Now, you will have the formula. If you haven't done this one yet, pause the video. Okay, so let me write this down. We can use the formula n choose r. Okay, and then we have our a to the n minus r and b to that r here. Okay, what I'm actually just going to do, I write the formula down. I know I need n choose r, and then I know I have the first term and the second term. I have 1 minus x, like this. Now my n is the power I have. The r is the power linked to the x. Now what's really important here is it depends which one's which, so which place these are. Now we know from our formula, because it's a n minus r and b r, whatever power this one has is our r. So if the x and the 1 were the other way around, you'd have to be really careful. Okay, however, we know that we need a 7 here, which automatically means we need a 3 here because these two add to make 10. And also that means that r is 7. Now be careful that, because if this was x and 1 this way around, we would have had 7 and we would have had 3 and r would have been 3 because it's whatever value is on the b. So I'm just going to rewrite this underneath. I have 10 choose 7, 1 cubed times negative x to the 7. Okay? And I've got 10 factorial divided by 7 factorial times 10 minus 7 factorial, which equals 10 times 9 times 8. And then it goes times 7. But underneath here, I have 7 factorial times 3 factorial. Now, this one and this one cancel. So I'm going to be left with 9 times 8 is 72, so 720 divided by 6, because that is 3 times 2 times 1. And then 72 divided by 6 is 12. Add the 0, so 120, okay? This is the coefficient that is going to go here. Okay, now we're going to have a little look at the sections of this. So you have 1 cubed, which is just 1, and here we have negative x to the 7. So it's like negative times a negative is a positive. However, because I've got an odd power, it's just going to be negative. So I've got 120 times 1 times negative x to the 7, which becomes negative 120 x to the 7. Find the term, so it's this one. Okay, and moving on to the last example I'm going to go through here. Again, if you haven't done it, have a go at it. Okay, and I'm just going to go through the steps with this one. Okay, so the first thing you should do is rewrite this, because we don't really want to use a fraction. We're going to turn this into 3x minus 2x to the minus 1, then to the 12. Okay, really important now, we know that we have n choose r, okay, then we have 3x, then we have minus 2x to the minus 1, and this is the way we're going to look at it here. Okay, so this is going to be n minus r, and this is going to be r here. Okay, what's important here now, we need the constant term. We actually don't know what r is going to be, but what we do know is the 2 powers, okay, here and here, okay, need to add to make 12, but also if it's a constant term, that means we get something x to the 0, because that becomes 1. So a constant term is the number that's constant that isn't affected by x. So basically, which one's just the number? So then we want to think about, okay, let me erase this, it's a little messy. I need a number here and a number here. And interestingly, look here, this is going to become a negative. So basically 2 numbers that would add to make 12. But when I do this one, add the negative of this one, I get 0. Okay, well, it doesn't always work using half because these powers might be different, but we're going to use 6 and 6 here because I can see that 6 would be here and negative 6 would be here. So they're going to cancel, they're going to make x to the 0. Now I can see that r needs to be 6. It's not always the case, you've got to be really careful with this. So we have 12, choose 6, and then we have 3x to the 6. And we have minus 2x to the minus 6. Okay, oops, I'm going to take that 6 out just for a moment because I was missing something. Okay, now here we've got 12 choose 6. So you can grab a calculator if you wish for that. So we're going to have 12 factorial divided by 6 factorial, 12 minus 6 factorial. Okay, and then here, be mindful, although our x's are going to cancel, we actually have 3 to the 6, x to the 6. That is this bit here. Okay, and then this bit here is going to become negative 2 to the 6, x to the minus 6. And we're timesing all of these things together. Okay,